There's a certain type of sequence called the geometric sequence that we'll use in upcoming discussions quite a lot. But before we get to those things, though, we actually figure out what talk about what a geometric sequence is. A geometric sequence is a specific type of sequence where each term, to get the subsequent term, you multiply by what's called the common ratio. For example, 2, 4, 8, 16, 32, about the most basic of a geometric sequence you could have, because each term, to get the next term, you multiply by 2. And so that's how a geometric sequence works. You multiply by the same number to get the next term. Okay? All right, so that term you multiply by each time, that is called the common ratio, R. And it's called the common ratio, R, because ratio means divide, take two things divided. Yeah, if you look at the ratio of terms, 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. So that's what they mean by the common ratio. So in this case, R is 2. So anytime you have that common ratio like that, it's a geometric sequence. Now, what we might note here is kind of the generating expression. You know, we talked about that last time. If we wrote it as a sub n, you got to figure it out. What would a sub n here be? 2 to the nth power, yeah. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. So it's 2 to the nth power. Now, similar generators will give you geometric expressions as well. If you go 2/3 to the nth power, just write out the first 5 terms. There you've got 2/3 would be the first one, then 2/3 squared would be 4/9. 2/3 cubed would be 8 over 27. And so forth and so on. You can see there that, what was the next one? 16 over 81. Oh, it's the first one. 32 over 243. Be the first 5 anyway. So I did them right. That was right. Yeah, so that also is a geometric sequence because, yeah, each time you are just multiplying by 2/3 again. 2/3 times another 2/3 times another 2/3, right? So the common ratio here is the 2/3. So that is geometric. Now we can get some negatives involved. -4 to the nth power. So yeah, that's -4, that's 16, -64, 256, etc., etc. Yeah, and so in that case, is that geometric? Yeah, because there's a common ratio. Each time I'm multiplying by -4, R here is -4, so I think we can kind of see the thing here. So yeah, that is geometric. It is a geometric sequence, and the R is -4. Now, one thing to note about that is that's got alternating signs, doesn't it? And so geometric sequences can have, you know, all positives, could have all negatives, but they could also alternate signs. And the deal is when they alternate signs, you're going to wind up having a negative ratio when you have that, when you have the alternating signs. Now, one last one here. All right, so this one is 5 times negative 1/2 to the n plus 1. Is that, think that was geometric? Well, let me give you the terms here. 5/4, and the next one's negative 5/8, third one's 5/16, fourth one's negative 5/32. Is that geometric? What's the ratio here? Negative 1/2.
So, yeah.
Yep. Yeah, that one is also. So yeah, you can kind of see the basic format for a geometric, but this also is geometric. And so kind of the distinguishing characteristic there is, yeah, you can have other stuff, but the distinguishing characteristic is you've got a number raised to the nth power. Now it could be the nth power, it could be n plus 1 power. There's some other possibilities there, but that's the basic thing you need. You need a number to a power, the nth power. And then you can have some other extraneous stuff to it, but yeah. And the other thing is the ratio. Usually you can tell if you've got it in this format, the ratio is going to be that base number right there, right? What you're raising to that nth power each time. The ratio is the number that you're raising to that nth power, and then you might have some other stuff to go with it. But anyway, that's our geometric sequence. Now the other thing to mention here, we also talked about convergence and divergence. Well, if you got r equals 2, is that geometric sequence going to converge or diverge?
Diverge.
That's diverge, yeah. It's not going to any particular number. It's going to infinity quite fast. Now, just looking at the other ones here, do you see any of these that converge, you think? I mean, it would probably be easier if we had it in decimal or we kind of graph these out. But yeah, if you look at these decimals here, these all are, they're getting closer and closer to 0. Same thing here. I mean, these are bouncing. This is one of those that it kind of bounces around, but they are both converging into 0 here. So this one converges and this one converges. And these top two diverge, right? Because that one's bouncing around, but it's doing this thing, right? -4, 16, -64, 256. It's just spreading out, isn't it? All right, so the top two diverge, the bottom two converge. Now, the distinguishing mark then of those two, what's the difference between these two? Well, if you look at the ratios here, 2/3, -1/2, and the ratios here, -4 and 2, it turns out for the geometric sequence to converge, that ratio has to be between +1 and -1. All right, so a geometric sequence converges if the ratio is between -1 and +1. And technically, you can include +1. Do you see why? Because if I had a sub n equals 1 to the nth power, what are the terms of that? 1, 1, 1, 1, 1. Okay, so that does converge. So technically that one does. Now, a sub 1 is -1, does not converge because why? Yeah, it just bounces around. It doesn't ever go to a specific number because it just bounces between -1 and +1. So that one doesn't converge, but the one does. It's not real meaningful, I guess, in a sense there. But anyway, that's when a geometric sequence converges. If that R is between a -1 and a +1, basically, basically there. So it's got to be some fractional part of 1 or the decimal. Works as well, but, okay, so that's our geometric deal. So I guess we could specify out then. So it diverges when? That would be everywhere else. So it diverges if R is greater than or equal to, R is greater than 1, or if R is less than -1, or equal to. Okay, so that should get us started a little bit on the geometric. We'll say more about that